Guys, so this week, we are looking at two sections. So this week we've got two sections. The last couple of weeks we've only had one section. So you've got a little bit more on your plate. Plus today and this week, we're not just doing two sections. We're going to be proving things, okay? So your homework and your practice needs to include proving things. I'm telling you, you're going to have a test the week of Thanksgiving, which is 3 weeks away. You're going to have a test on this, and you're going to be asked to prove some things, okay? So we're going to be proving things. The level of difficulty is going to go up just a little bit. Here's our objective, and these things right here aren't going to make any sense right now, but they will here in a few minutes. I'm going to explain those. Our objective is to prove that two triangles are congruent. And we're going to use whatever those things are, SSS, SAS, and all that stuff, okay? So first of all, let's talk about what are congruent figures. Well, we just did that in section 4.1, didn't we? Section 4.1 was about congruent figures. And what we said was this: congruent polygons have congruent corresponding parts. All of their matching sides and all of their matching angles have to be congruent. So if you have two quadrilaterals here, how many total corresponding pairs do they have? They have 8 different things. So in other words, if you wanted to talk about this quadrilateral, I'll call it quadrilateral 1, and quadrilateral 2 being congruent, you'd have to show 8 things. You'd have to show that this angle is congruent to this angle is congruent, all 4 angles, and then you have to show that this side's congruent to this side, all 4 sides. That's a lot of stuff to do in a proof, right? In this section, we are looking at proving what? Triangles are congruent, right? And that should say triangles. So how many things are we going to have to prove then to prove them congruent? 6. So if we're going to do triangles, it seems like it's going to be 6. That's still a bunch, isn't it? I'm going to give you a little hint. Guess how many things you're actually going to have to prove two triangles are congruent? Count the letters. Now, I'm trying to make a point here. If you're going to use this definition to prove two figures are congruent and they're triangles, you'd have to prove 6 things. That's a lot. But if you use these 4 things, these postulates or theorems, you only have to do 3 to prove them congruent. Okay? So let's see an example of that, hopefully. Maybe. Oh, there we go. Went a little too far. And here they are. Here's an example of each. And by the way, I put summary this. I could have put this at the very end of the slides. I'm putting it right in front, though, so that you can kind of see an example of each. SSS. Guess what SSS stands for? Side, side, side. In other words, if you can prove that this side's congruent to this side's congruent to this side, and this side's congruent to this side, then guess what has to be true about the two triangles? They have to be congruent. In other words, if this was 20 degrees, guess what I know has to be true about that angle? It's also 20 degrees. So that's SSS. Here's another one, SAS. Can you guess why it's SAS? Side angle side, right? Now here's something I'm going to talk about more in a minute. It turns out that this angle, that A has to be in the middle. And you could probably guess if I spelled it A-S, that'd be kind of a bad word, right?
Indeed.
Well, there's a reason that A is in the middle, and it's not because we don't want to write a bad word. It turns out that A is in the middle, and this is an important concept because it has to be the included angle. We'll talk more about that in a second. Can you guess why this one's called ASA? Angle side angle. So if I can show that an angle is congruent to an angle, a second angle is congruent to another angle, and then this is that word again, that included, the included side, then they're congruent. And then finally, AAS. And this, by the way, notice that these two guys look kind of the same, but guess where the S is on this one? It's at the end. This one does not have to be included. So this one is not included. Now, guys, I'm just letting you know that I've went over all of this stuff in my presentation online, but I'm going over it again because this is really important for you guys to get. Okay, so let's go ahead and look. We have 2 postulates we're going to focus on first, which is SSS and SAS. I would recommend that you read the words for these. It says, if 3 sides of a triangle are congruent to 3 sides of another triangle, guess what you can conclude about the triangles? They're congruent. Now here's that included thing. SAS. So this is SAS. This over here was SSS. If you have 2 sides and the included angle, now let's talk about that. Do you guys see this side here and this side here? What would the included angle be? And by the way, I haven't even told you what it is. I'm just asking you. It's angle A. You know why it's called the included angle? Those 2 sides, what angle do they form? They form A. So this is what we would call the included angle. Does that make sense? This is the non-included angle. Guess what they call this one over here? Another non-included angle. This one's the included angle. Okay? Kind of an intuitive thing. By the way, if you have a side, and included angle that are congruent on 2 triangles, then the 2 triangles are congruent. So let's look at an example here. Sorry, I got a little animation here. So this is a proof. This might be something you'll see on your next test. It says there's some given information, and we're supposed to prove that those 2 triangles are congruent. We're trying to prove that, I'll call this triangle 1 and triangle 2 are congruent, right? Who can give me the reason for the first step? What's usually the first reason? It's almost always given. By the way, let's check that. Was this given? Yeah, so that's given. Okay. Now look at step 2. It says the reason is definition of segment bisector. So we said that Y, this point right here, that's what this is a point, is a bisector of that segment. Can anyone guess what we can conclude about this segment and this segment then? They're equal, or we'll call them congruent. So I'm going to say that segment XY is congruent to segment, I'll call it YW. Because that is the definition of a segment bisector. A segment bisector divides it into 2 congruent segments. Now, what does step 3 say? It says given. What else was given? These 2 guys. Oh, by the way, I should know. I'm going to go ahead and mark this guy congruent to this guy. And I need to go ahead and, I guess that was given as well, wasn't it? That was given as well. So here's the thing I need to do, though. I need to make this a different marking. You guys understand why I do 1 markings and then 2 markings? If I left all of those as 1 marking, I'm saying that all 4 of those are congruent, right? That's not what I'm trying to say here. Okay, so this is XV congruent to VW. Now, by the way, I'm going to stop here for a second. This is a proof. Has it been really hard thus far? Probably the hardest step for most of you guys would have been this step right here, correct? Now, this is my favorite question. I love this question. This one gets me so excited because it's so easy, but students struggle with it. Why is this segment right here congruent to itself? What? It's kind of funny. I'm trying to think. I know, they can't remember. They never can remember. We went over this in chapter 1. What? Close. He said reflective. That's close enough. It's reflexive. Excellent job. This is the reflexive property way back. Reflexive. That is exactly right. Good job. I'm giving you a smarting on that one. That's good. Reflexive. All right. I just never can remember that one. That's my favorite property. We use it all the time. Okay. So, by the way, now we got this and this. Now, can you guys tell me why the 2 triangles have to be congruent? I'll give you a hint. It's either this. It's one of those 2. Which one is it? Look at the picture. It's SSS, isn't it? So this answer is going to be SSS. Oh, by the way, what's going to have to go over here for the last statement? Whatever it is you're trying to prove, always is the last statement. So this is triangle XYV congruent to triangle WYV. Proof is done. Now, was that terrible? Nope. It's a lot harder though when you're doing it by yourself, isn't it? And it's a lot harder when you're doing a test and you don't have your list of theorems and definitions and all that in front of you, which some of you didn't do last week, okay? Questions on this proof?
Mr. Allen, can I say something real fast?
You can say something.
Hey guys, listen to me. I don't say it very much when I say something to you. I usually think it's important. I've sat through like 6 geometry classes, including the one that I took in high school, and I did not know that the reflective property. Okay? If you
Going. All right. All right, guys, look at A. I'm going to call on you. Anthony, A, which of these, SSS, SAS, which of those do you think makes A, those two triangles congruent? Do you think it's SSS, SAS, or neither? Not enough information, I guess I should say. SAS. Okay. B, let's go with Ishmael. What do you think? SSS. And C, let's go with Vaughn.
SSS.
Okay. Thomas. You agree with all those answers? You do not. Which one do you I disagree with one of them as well. Which one do you disagree with? I agree. B is incorrect. What is the correct answer for B, guys? Nope.
It's A. It's
Not enough information. Look, guys, you see how this angle is included? See how it's included over here? Is it included over here? No, it's a trick. So you have to make sure that the angle is included. Notice it's SAS. This would spell ASS. Don't make a ASS of yourself, okay? Always have to throw that little joke in there. Okay. Questions on there? By the way, this one is correct, and this one is correct as well. All right, let's go to the next one. Okay, so we did SSS and SAS. Now I got 2 more and we'll be done. ASA, that means if 2 angles and their included side are congruent, the 2 angles and their included side, if they're congruent, then guess what you can conclude? Triangles are congruent. But it has to be in that order, SAS. Now this one's a little bit of an oddball. This one says if we have AAS. So this one is when we're talking about a non-included side, which is kind of weird. But notice it doesn't spell a bad word. It's just AAS. This one is ASA. The only difference between the two is if the side is included or not. That's the difference. Okay, so let's look at an example. And of course, I put a little bit of animation there. Let's do another proof. This one's got 5 steps. Step 1, what do you think the reason is? Actually, you know what? Let's take a minute here before we start answering the questions. So there's some given, there's some proof. All right, so here's triangle 1, here's triangle 2. We're trying to prove those 2 triangles are congruent. That's what we're trying to do today. Prove triangles are congruent. And I'm telling you right now, the answer is going to be either ASA or AAS at the very end. Okay, it's not this. I'm telling you right now, this is not SSS or SAS. We did that a minute ago. We'll come back to that later. So what do you guys think the reason is for step 1? Well, yeah, it's given. It's almost always given on the first step. Now, someone make my day. Ishmael, you're out on this one. If this line right here, notice how I got these little extra arrows here. If this line's parallel to this line, the reason is alternate interior angles theorem. Can anyone tell me which 2 angles have to be congruent? Which 2 angles have to be congruent? And I'll give you a hint. It's not one letter. You cannot name it with one letter. I'm not talking about angle M and K. We've already talked about that right there. This was on your test last week, and this was something that some of you struggled with. Alternate tier angles. I'll give you one more hint. This right here, we'll call this line, we'll call it line T for transversal. And then we have these parallel lines like this, right? Which angles are congruent by alternate tier angles theorem? Say again?
W.
Now, you can't just say W. The reason you can't just say W is there's multiple angles there. Are you talking about angle MWR? Or are you talking about MWK?
WK.
Nope. It is MWR. So it's going to be angle MWR. And let me do that in a different color here. Let's do that in purple. That's this angle here. You guys see that angle there? That angle there. What's it got to be congruent to? What other angle? Nope. Not RMK. KRW. KRW. Guys, this was your test last week. Yeah, you forgot about that. Those are alternate tier angles. Remember, this is the transversal. This purple line's the transversal. Are these two angles on alternate sides of the transversal? Are they inside the parallel lines? That's alternate tier angles. Okay, so we've got an angle congruent to an angle. Oh, and we're given that this angle, M, is congruent to this angle, K, correct? Uh-oh, number 4. Ishmael, you're out again. I said reflexive property. Who can tell me what has to be congruent to what because of the reflexive property?
Come on, baby.
Sean? I'll give you a hint, purple. Segment WR is congruent to what? No! To itself, Sean.
Oh my God.
WR is congruent to?
So,
Which is?
WR.
WR. Very good. There we go. All right. Now look here, guys. I'm going to draw my picture some. So we got this angle is congruent to this angle. This angle is congruent to this angle. And this side's congruent to this side. Now, I told you a second ago that the only two differences between this one and this one is whether or not the side was included, correct? Don't speak. I want you to look at the pictures and think, which one is this going to be? Is it going to be ASA or AAS?
Wait, can you go back?
Which one is it? What do you think, guys? A, this one? Ishmael, what do you think? You agree with that? Not sure? Tomas, what do you think? Or ASA, this one? You think it's this one? Sean, what do you think?
Think it can be AAS.
AAS? Okay, so we got 2 people for this one. What do you think, Vaughn?
Kind of tricky.
It is tricky. Not sure? Anthony? Oh, you already said this one, didn't you? This is the right answer. This is the right answer. Guys, look. You've got this angle and this angle, correct? Is this side the included side?
No.
No. Look, these 2 angles, this would be the included side, wouldn't it?
Yeah.
So these are that's the non-included. So this is going to be, let's do this in red. This is going to be segment, AAS. And now, by the way, what's always the last step? Whatever it is you're trying to prove. Now, guys, do me a favor. This is something that some students do, and it kind of is a pet peeve of mine. Don't ever write prove there. Students will say prove. No, that's not what you write. This is what I'm trying to prove, so you write that there. Does that make sense? Okay. All right. So here's a multiple choice question. We're almost done. This should be, I think, the last one. We got 2 triangles, agreed? It says, use the diagram at the right. Which of the following statements best represents the answer and the justification for why is triangle BIF congruent to triangle UTO. BIF and UTO. Okay, does anyone feel confident about their answer here? So this could be a question on your next exam, right? Now we're talking a few weeks in advance. Does anybody think the answer is A?
No.
Nobody thinks, okay, good, I agree. Does anybody think the answer is B?
C.
You think it's C, okay. The two triangles are congruent by AAS. Okay, so now we got BIF, BIF, and then UTO, correct? We've got this angle congruent to this angle congruent to this angle. Uh-oh.
That's what I said. DOT.
We would need this side to be congruent to this side. Or we would need, since this side's, we'd need it to be congruent. So guess what the answer is? B.
Yeah, that's what I said. This.
This is incorrect.
I was thinking too fast.
FB and OT are not corresponding sides. Remember, this congruent statement tells us that FB, that's this letter and this letter, has to match up with this letter and this letter. In other words, BF, or actually let me write it the way they wrote it here. FB has to be congruent to, okay, so it was the last and the first, so it has to be OU. And that's not the case here. We're not given that, so we cannot prove that these two triangles are congruent. Okay, I'm going to stop it there. You got a few minutes left here.